Hi, my name is Professor Scott Brown from the School of Psychology at the University of Newcastle, and in this video I'm going to talk to you about populations and sampling. I'll tell you what those terms mean in a psychological framework and what different kinds of sampling techniques can mean for the external validity of your study. Let's get started. In psychology, you'll hear a lot of research referring to a population. When people hear the term population, they might think about how many people live in a certain country, like the population of Australia is about 25 million people. However, in psychology, the term population means something a bit more specific. When we talk about a population, it's the entire set of people that a researcher is interested in. Sometimes that might be something very broad, like the population of a country, but usually it's a bit more specific. One example of a population of interest could be all females in Australia aged between 25 and 40 who have a bachelor's degree. Another population of interest could be all of the people in a clinical trial who've tried a certain type of anti-anxiety drug. The population of interest all depends on the research question for the study. As well as the term population or population of interest, you'll often hear the word sample a lot in psychological research. A sample is just a smaller group taken from the whole population of interest. But why would we use a sample and not just the whole population of interest? Well, sometimes the population of interest is just too large to be able to use practically. For example, suppose that the population of interest was all the people aged between 25 and 40 in Australia. Accessing all of those people and getting results from them all is just not practically possible. And so a researcher will draw a sample, a smaller set, from that population. A sample of people from the population helps the researcher obtain interesting results without the practical difficulties of accessing everyone in the population. One thing we need to make sure of is that our study has external validity. What this means is that the sample we choose has to accurately represent the population of interest. For example, suppose we're interested in the Netflix viewing habits of Australians. Then the population of interest is all Netflix viewers in Australia, and we would have to make sure that the sample of Netflix viewers we choose accurately represents all of the Netflix viewers in Australia. This ensures that our study would have external validity. There are a number of ways we can do this with different sampling techniques. When we take a sample from the population, we need to make sure that the sample is representative. That is, we need to make sure that all members of the population have an equal chance of being included in the sample. This gives our study external validity, and it means that we can make inferences about the population from our sample. We call this type of sample random sampling or probability sampling. The most basic type of representative sampling is simple random sampling. An easy way to imagine simple random sampling is if everyone in the population has their name written on a piece of paper and put into a hat. Then the researcher reaches in and draws out however many pieces of paper they need to make the sample. A common way to do this in practice is to assign everyone in the population a number and then to use a computer to generate a sample randomly from those numbers. Now, the name simple random sampling might make it sound like this is always a simple and easy thing to do, but in practice it can be a bit more tricky than it sounds. Let's look at a few more types of random sampling. Cluster sampling is where clusters or groups of participants are randomly chosen from a population, and then all of the people in those clusters are used for the sample. Imagine that Professor White is doing a research project on the experiences of first-year uni students in New South Wales. To use the cluster sampling technique, Professor White would first select, say, 5 universities from New South Wales, and then sample all of the first-year students from those universities. Multi-stage sampling is a very similar technique to cluster sampling. It's just got one extra step. In multi-stage sampling, we draw 2 random samples. First, we draw a random sample of clusters, just like in cluster sampling. But secondly, we draw a random sample of people from within each cluster. Going back to the example of Professor White's project on the experiences of first-year uni students in New South Wales, she would first select, say, 5 universities from New South Wales, and then she would draw a random sample of first-year students from within each university and use those for her sample. A specific type of multi-stage sampling is stratified random sampling. This is where the researcher selects specific demographic categories on purpose and then randomly selects individuals from those categories. In Professor White's uni student example, she might be particularly interested in how the living conditions of the students affects their attitude and performance in first year. So she might break the population of interest into 3 broad demographic groups: Australian students who live at home, Australian students who live out of home, and international students. First, she would find out what percentage of students make up each proportion in the population. For example, maybe 30% of Australian students live at home, 50% are Australian students who live out of home, and 20% are international students. Then, she'd randomly sample students from each of those demographic groups and make sure that the proportion of each group in the sample stays the same as in the population. A variation of stratified random sampling is called oversampling. This is where the researcher intentionally overrepresents one or more of the categories in their sample. This strategy is important when one of the categories has a very small proportion of people in the population. By oversampling, the researcher can make sure that there are enough people, even from that very small category, in the sample to make an accurate representation of the population. The last type of representative sampling technique that we'll look at in this video is called systematic sampling. This is where the researcher counts off members of a population using a randomly chosen interval. It's not as complicated as it sounds. Imagine that a lecturer wants to survey the people in her lecture theatre on a particular topic. Instead of surveying everyone in the lecture theatre, that's the population, she surveys just a sample of the people. To use systematic sampling, she would choose 2 numbers, say 2 and 5. Then, to get the sample, she'll start with the second person in the lecture theatre and then count across the chairs and use every 5th person until she has her sample. We start by selecting the second person and then every 5th. So that's 1, 2, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4. Before we move on to talk about biased sampling techniques, I just want to make sure you understand the difference between 2 terms that are sometimes confused with each other: random sampling and random assignment. Random sampling is what we've just been talking about. It's where a researcher creates a sample using some random method, such as drawing names out of a hat, to make sure that each member of the population has the same chance of being included in the sample. Remember that random sampling improves external validity. Random assignment is used in experimental designs. When researchers want to put participants into different groups, maybe a treatment group and a control group, they assign the participants at random, maybe by flipping a coin. Random assignment enhances internal validity. Random assignment enhances internal validity by ensuring that the comparison group and the control group have the same kinds of people in them. By randomly assigning the people to groups, we can be sure that the groups don't differ in some other way before the experiment begins. The random sampling techniques we've spoken about so far are representative. That is, they make sure that all members of the population have an equal chance of being included in the sample. When a sample is not representative, we call it biased. When a sample is biased, it means that some members of the population have a much higher probability of being included in the sample than other members. When a sample is biased, it makes it difficult to draw correct conclusions about the population from the sample. One bias sampling technique is called convenience sampling. Convenience sampling is where a researcher uses the people who are most convenient for their sample. Imagine this scenario. Professor Green is investigating the recycling habits of people in his community. He's defined his population of interest as all the people who live in Mayfield who are 18 to 40 years old. Now, Professor Green has a deadline and he needs his research report written fairly quickly. So he chooses to survey the people in Mayfield that he has quick and easy access to. This sampling technique will likely not give a true indication of the recycling habits of the community. This is because not all members of the population have an equal chance of being included in the sample. Another example of convenience sampling is when researchers use landline polls to survey members of the population about a certain topic. The problem with this is that many young people don't have landlines, they just prefer to have a mobile phone. The sample in this case, presumably an older group of people who have landlines, would not have an equal probability of including older people and younger people. The younger people will be underrepresented and the older people will be overrepresented. biased samples aren't ideal for a study. As we know, representative samples are much preferred. However, in some cases it's not always possible to get a representative sample of the population. And sometimes, where external validity is not vital to the study, we might choose to settle for a biased sampling technique. An example of convenience sampling that's often used for studies is where the researchers at the universities advertise for psychology students to participate in their studies. Remember though, that when writing a lab report or a journal article, we need to report the type of sampling we used, so that the reader knows how to properly interpret the results. A second type of bias sampling is self-selection. This is where a researcher only uses people who volunteer for the study or self-select. The problem with this is that the people who self-select are usually very motivated or feel very strongly about the research topic, and so they don't truly represent the population. Imagine this scenario. Professor Green is investigating the religious views of people in his local community. He's again defined his population of interest as all people living in Mayfield who are 18 to 40 years old. Professor Green puts posters around the community asking for people to contact him who are interested in completing a survey on their religious views. The people who respond to Professor Green's posters are likely to be people who have strong religious views or who are particularly interested in religion. Therefore, these people, the sample, are not likely to represent the population as a whole. People who have no strong opinions on religion are just not likely to respond to Professor Green. Another example of self-selection is when students are asked to give feedback on a course at the end of semester. The students who respond are likely to be very motivated to give their feedback. Often this would mean that the students who've had a very good experience with the course or a very poor experience with the course would be the ones who complete the feedback form. In this case, the sample, the very satisfied and the very dissatisfied students, is biased by self-selection and is not truly representative of the population, which is all of the students in the course. Purposive sampling is another type of biased sampling technique. This is when researchers only want to study certain kinds of people. For example, suppose a researcher wanted to study the effects of a new smoking intervention, then they would purposively sample smokers for their study, maybe by putting up flyers at a local tobacconist. Snowball sampling is a variation of purposive sampling. In snowball sampling, each participant is asked to recommend a few more participants for the study. Snowball sampling is often used when the population of interest is small, hard to recruit from, or difficult to access. Maybe people who have a rare disease. The last type of biased sampling technique we'll talk about is called quota sampling. Here, the researcher identifies subsets of the population and then sets a target number, or quota, for each subsample. For example, the researcher might be interested in left and right-handers, and so they'll set a target of 100 left-handers and 100 right-handers, and then sample non-randomly from the population until those quotas are filled. Quota sampling is similar to stratified random sampling that we talked about earlier, except that in quota sampling, the participants are sampled non-randomly from the population. Sometimes, researchers use a combination of sampling techniques in their research. In the future, when you read journal articles, see if you can see what kinds of sampling techniques the researchers used. You'll find this information in the methods section of the article. And the next time that you hear a claim about a population made in the media or in advertising, think about the type of sampling that might have been used to support that claim. For example, 97% of women agree that this product reduces wrinkles in just 2 days. The main thing to take away from this video is that you need to do everything you can to make sure that your sample represents your population of interest. That makes sure that your study will have external validity.